So we've talked about money and the different formulas in relation to money. So we're going to go through all the examples now. There are a lot of examples in this section, and so we're going to do that right now. Let me grab a pen real quick. Okay, so example 1. Tom and Harry Sporting Goods marks up all clothing 75%. If their cost for a shirt is $15, what retail price will Richard have to pay? And so we had a bunch of equations or formulas that we could plug things into. And so we want to know the retail price, and we have the cost and we have the markup. And so from our list of formulas that you have on the first few pages of this notes, we know that cost plus markup equals retail price, and that markup equals markup rate times cost. So we can put these two together and we can get cost plus the markup, and we know that the markup is markup rate times the cost, and that equals the retail price. Okay, so that is our retail price. I'm gonna get a skinnier pen here so that I don't take up so much room. Okay, so now we just have to plug in. So first we have cost, and the cost is $15. So we'll put $15 plus the markup rate, which is 75%, and we always convert that to a decimal to do the math, 0.75, and then the cost, which again is $15, and that equals our retail price. And then you can plug this into your calculator. It's okay to use a calculator for this. And so what we get is we get $26.25. And for this and for all others, when you're dealing with money, you always want to round to the nearest cent. You may get an answer that has a bunch more numbers after the hundredths place, but you can't pay part of a penny. So just round to the nearest cent when dealing with money problems. Okay, so that's how you do example 1. Let's move on to example 2. Determine the retail price of a tennis racket if Paulo saved $52.50 by buying it during the 30% off sale. Okay, so we want to know the retail price, and then we want to know how much did he pay for it on sale. Okay, so we have two things we want to know. We want to know the retail price and the sale price. Okay, so we have the retail price, and we also have the amount that he saved, and we have the discount rate. So we have the discount rate, and we want to find the retail price. So we know from our formulas that discount equals discount rate times retail price. Okay, so we can plug in and solve. So we can put the discount was $52.50, and the discount rate was 30%, converting that to a decimal, 0.3, and then times the retail price. So to find out the retail price, we would divide $52.50 by 0.3, and that will give us the retail price. So once again, feel free to use a calculator at this point. So if you do that on a calculator, you will get an answer of $122 and, sorry, I'm looking at the wrong line on my notes. I was thinking that doesn't sound right. You would get an answer of $175 retail price. $175 retail price. Okay, but that's not all it asks. Then it wants to know how much did he pay for it on sale. So we know the retail price, we just solved for that, and we know how much he saved, so then we can figure out the sale price. So we're going to take the retail price, $175, and subtract how much he saved, $52.50. And when you calculate that, that's where you get $122.50. That's the line I was looking at just a moment ago. $122.50 is the sale price. Sale price. Okay, so from just knowing how much he saved and what the discount rate was, we were able to find out the retail price and the sale price. So let's go ahead and look at example number 3. It says determine the retail price of a pair of running shoes and the discount if they are 40% off and have a sale price excuse me, of $54. So we know that the discount rate is 40%. We know that the sale price is $54. We need to know the retail price and the discount. Okay, so we want to know the retail price and the discount. So we know that the sale price is equal to the discount rate times the retail price. So we can use the given information and we can solve for the retail price. We know the sale price is $54. The discount rate is 40%, which translates to 0.4 times the retail price. We're going to divide both sides by 0.4 to isolate the retail price, 0.4, and that gives us a retail price of $90. And then we can check these, right? And we should be checking them. I don't want to take that much time on a video, but we can quickly see, well, 40% is almost 50%. And so if it was a $90, 50% would be $45. And so that's about right. So we're in the right ballpark. But we're still not done because it wanted to know what the discount was. Okay, we have the discount rate and we have the retail price. So there are two ways we could do this. We could multiply the discount rate times the retail price, or we could subtract the sale price from the retail price and we would get the same answer either way. Let's just go ahead and subtract. So we want the discount, and that equals the retail price minus the sale price, and that will tell us how much was taken off. So we're going to say the retail price is $90 and we're going to subtract $54, and that gives us a discount of $36. A $36 discount on the shoes. Example number 4. So now we're working on commission rate. Now we're working with a different set of equations. Remember we said that commission equals commission rate times sales. Okay, so let's see what this says. Oops, and this should say find. Sorry, typo there. Find Jeff's commission rate, so this is what we're finding, if his total sales of electronic equipment for the month were $8,250 and his gross income for the month was $3,660, including a monthly salary of $2,175. Okay, so there's one step in here that we need to do first before we can plug this into our commission formula. First, we need to find out how much of his income was commission. Okay, we know his total income, but that includes a salary. So that's money that he makes regardless of how many sales he makes. So first let's figure out how much of his income was commission. So we're going to subtract, we're going to take his total income and we're going to subtract his salary, and what's left will be his commission. Okay, so we'll do some borrowing here. We get 5, 8, 4. So $1,485 of his income was commission. Okay, so now we can plug this stuff in. So we're looking for his commission rate. We know his total sales and we know his commission amount. So let's plug this in. We get $1,485 equals his commission rate times sales, and his sales were $8,250. $8,250. Now to find the commission rate, we're going to divide both sides by 8,250. 8,250. Divide this by 8,250. Right? These two cancel out, leaving just the commission rate. And then we can plug that into a calculator, and what you would come up with is 0.18 as the commission rate. Now we want to know a commission rate in percentage, so to convert this to a percent, we would multiply times 100%, which equals 18%. So Jeff's commission rate is 18%. On the next page, on the next page, we have a few more examples. These ones involve the investment or interest formulas. So Christopher invests, well, let me go ahead and write that up here just so you have it to look at. Interest equals principal times rate times time. There you go. And this is simple interest. When you get up into higher math, we'll talk about compound interest, which is more realistic. But in this case, we're going to talk about simple interest. Christopher invests, Christopher invests the same amount of money in each of 2 accounts and receives a total of $36 interest at the end of 1 year. If the accounts earn 5% and 7% interest, how much was invested in each account? So let's go ahead and put our known information into this table, and then we're also going to choose a variable to represent our unknowns. So we know that he received a total of $36 interest. So what that means is if we take the total of the interest from both accounts, the total would be $36. Okay, and we're talking about the end of 1 year. So the time on both of these accounts is going to be 1 year. If the accounts earn 5% and 7%, so we can put those in under our rate. Now remember, we have to convert that to decimal. So we have 0.05% interest and 0.07% interest. And what we want to know is how much was invested in each account. So we are looking for our principal here. Okay, we're looking for the principal. So let's assign X. Let's say X equals the amount in each account. Okay, and this makes it easy. We can just put X in both of those because they have told us that Christopher puts the same amount in each account. When you get into Algebra 2, you'll have different amounts, and so they actually made it easy for us here. And so what we know is that from our interest formula, we know that if we multiply principal times rate times time, that equals the interest. So let's go ahead and come up with expressions to show how much interest is earned on each account. So we're going to multiply P times R times T. Because T is 1, we can ignore it. When we multiply anything times 1, you don't necessarily need to write it, but we do need to put these other ones. 0.05x is the amount of interest earned on the first account, and 0.07x would be the amount of interest earned on the second account. Okay, and we know that the total of those two together is $36. So now we can write an equation that has x in it and solve for x to find what our principal was. So we know that 0.05x is the amount of interest earned on the first account plus the amount earned on the second account, 0.05x. Together, those equal $36. So then going back to eliminating decimals, if we multiply both sides of this equation by 100, we can get rid of the decimals and rewrite this as 5x plus 7x equals 3,600. Combine like terms, 12x equals $3,600. Let me scroll up just a bit here. Okay, and then we'll solve for x by dividing both sides by 12. Therefore, x equals $300. And then, so what does that mean? That means that Christopher put $300 in each account at the beginning of the year. Okay, our last example has to do with interest again. So let's go ahead and read this one. Robert borrowed $500 at a simple interest rate of 6%. 3 months later, he borrowed an additional $900 at 8%. If he paid off both loans at the same time and paid $33 in interest, for how many months did he borrow each amount of money? So we have a lot of information given to us, so let's start putting it in our table here. Robert borrowed $500, so that's the principal on one of the loans. $500 with a simple interest rate of 6%. So our rate is 0.06%. 3 months later, he borrowed an additional $900, so that's a second loan, $900 at 8%, 0.08. If he paid off both loans at the same time and paid $33 in interest, so that's the total of both interests together, for how many months did he borrow each amount of money? So our big question is the time. We don't know the time. So let's say that x equals the time of the longer loan. Okay, so we're going to put x in here, and then we need to come up with an expression for the time of the shorter one in terms of x. So we know that the shorter one was 3 months shorter, but we're going to convert that to years because we do our interest formula in terms of years. So 3 months is 0.25 of a year. So the length of this loan would be x minus 0.25 for those 3 months, which is a quarter of a year. Okay, now we know, because I equals PRT, that we can multiply PRT to get our I over here. So we get 500 times 0.06x, and we get 900 times 0.08x. And now we know that $33 is equal to both of these together. The total interest is the interest from the first loan and the second loan added together. So let's go ahead and write that out. $500 times 0.06x plus $900 times 0.08 x, and that, sorry, not x, this is x minus 25, so x minus 0.25, and that equals $33. Okay, so now what we need to do is we need to solve for these x's and see what the time was of the first loan. So we could multiply both sides by 100 and get some really big numbers, or we can recognize that 500 is 5 times 100 and then multiply that 100 into our interest rate here. So let's go ahead and do that. So it's 5 times 100, and I'm going to apply it here and make that a 6x. I'm going to do the same thing over here. 900 is equal to 9 times 100. So I'm going to take the 100 and multiply it times 0.08 and get 8 x minus 0.25 equals 33. Okay, now I'm going to go ahead and do some multiplication. 5 times 6 is 30. 9 times 8 is 72. X minus 0.25 equals 33. And then I'm going to scroll up because I'm out of room. Oops, shouldn't be an equals, this should be a plus. Sorry guys. Okay, now I need to distribute this 72. So 30x, I'm just going to copy that down. 72 times x is 72x. And then I have a positive times a negative, which means that's going to be a negative. Now, 72 times 0.25 is the same as dividing 72 by 4. So let's go ahead and do that. Rather than multiply times 0.25, I'd rather do 72 divided by 4. So 4 goes into 7 one time. We have 3 left over and a 2. That means 18. So 72 times negative 0.25 is going to be negative 18 is equal to 33. And then we can combine like terms. So we get 102x minus 18 is equal to 33. Move the 18 from this side over there to isolate the x term. 102x. Then we're going to add 18 and we get 51. Scroll up just a bit more. And then we want to get x by itself, so we're going to divide both sides by 102. 102. So then we get x is equal to, and 51 times 2 is actually 102, so we know that this is 1/2. Okay, so x is 1/2, but remember that's in terms of years. So a half of year is equal to 6 months. Right? So that means the first loan he had for 6 months, and let me scroll back up and see. They wanted to know how many months did he borrow each amount of money. Okay, so 6 months was the first loan, and then the second one would be the 6 months minus a quarter of a year, which is the 3 months, and that equals 3 months. Okay, so the first loan he had for 6 months, the second loan he had for 3 months, and that's how you figure out the time when you know the principal and the rate and the total interest.